Example 21.4 part C and D wants us to find the exact solution of each equation. Also be sure to reject any values of x that are not in the domain of the original logarithmic expression. Also acquire a decimal approximation. So here we have 6 times the natural log of 2x is equal to 30. Now, in order to be able to use the definition for log to exponent, I have to make sure that my logarithm has a coefficient of just 1. Right now it has a coefficient of 6. Now, because I'm working with a logarithm statement, I do have the option of taking 6 and moving it up as a power. But you also have the option of, instead of doing that, you could just divide both sides by 6. That will allow the coefficient to become 1 for the logarithm, and then the 30 on the right hand side ends up becoming smaller, just becomes 5. So there's nothing wrong with using the coefficient power rule for logarithms, but when you bring something up as a power, you typically are going to be making your values bigger. Whereas if I divide both sides by 6, it helps make your numbers smaller and typically a little bit easier to solve. So now when I convert this into exponential form, I'm going to end up with e to the 5th power is equal to 2x. Remember, e is the implied base on an ln. And now I would divide both sides by 2, getting e to the 5th divided by 2 is equal to x. And that represents the exact answer, the exact solution to this equation. The decimal approximation for that is about 74.207. And substituting that value of x back into the original logarithmic equation is not going to present any issues with us as far as the argument is concerned. So we'll box in the exact and the approximate solution there. For part D, we have the natural log of the square root of x plus 4 equal to 1. So here the square root of x plus 4 represents the argument of this natural log. But for this example, the natural log doesn't have any coefficient restrictions here. The coefficient is just 1, so not really any need to do anything there. I should be able to go straight to converting this to exponential form. Take the base e, the exponent will be 1, and then it's all equal to the argument, which is the square root of x plus 4. So now I'd want to look into solving this further by squaring both sides, so that way I can get the square root and the square to effectively cancel each other out, leaving me with x plus 4 on the right hand side and e squared on the left. Now I will subtract 4 from both sides, getting the statement e squared minus 4 is equal to x. Again, that represents the exact solution. The decimal approximation for that is about 3.389. And if I take that and plug it into the original argument, I will have absolutely no problems with that there. Everything's going to be positive and work within the scope of the square root as well. And so we'll box that in as our final answer.